Hi, Physics 2, Mr. Janowski here. So here we are on Homework 3, Chapter 32, and we're doing Problem 2. This is a good one to do. So Part A, what is the force of Q2 on Q1 in unit vector notation? So let's start with a step, What are we looking for? What units do we expect it to have? So step, we want F of 2 on 1. So I'm going to write it that way. F of 2 on 1. And it will be a force, so it's in newtons, but we want it in unit vector notation. So what that means is we want it to look like this. Question mark something I hat plus question mark something j hat in newtons. So that's what we're looking for. So how are we going to do this? We are going to use Coulomb's law. So Coulomb's law says that F, in this case, F of 2 on 1 is going to be equal to K, Coulomb's constant, times charge 2 times charge 1 over the distance from 2 to 1 squared. So now we go to the numbers. K is over here, 8.988 times 10 to the 9th. And I will leave off the units because the units for that are annoying, and I will run out of space if I try to include the units. So there we have times 10 to the 9th. What is Q2? Q2 is minus 6 microcoulombs. Be careful about the prefixes here. So it's minus 6.00 times 10 to the, what does micro mean? Times 10 to the minus 6 coulombs. So there's that one. And Q1. Q1 is 5 microcoulombs. So 5.00 times 10 to the minus 6 coulombs. Just barely fit it in. And all of this gets divided by the distance from 2 to 1 squared. So look at the numbers I've given you. So both of these are on the y-axis, so their x part is 0. And Q1 is at 0. Q2 is at 0.6. So their distance is 0.600 meters. And remember, that number gets squared. So I pick up my calculator and I do this. 8.988 EE9 times minus 6, more on that in a second, EE minus 6 times 5 EE minus 6 divided by 0.6 x squared. And what I end up with is F of 2 on 1 is equal to minus 0.749, and it's in newtons. So that's where we're at so far. But this is not, we're not done because this is not in the right format. This is not in unit vector notation. So how are we going to handle this? What does this negative mean? What's going on here? There are different ways to do this. I highly recommend doing it this way. Let's do the same thing, but with absolute value signs. So what's the absolute value of this? When you're dealing with a vector, if you put absolute value signs around it, I could have done more nicely. F2, 1. If you put absolute value signs around a vector, what that means is what's the magnitude? So what is the positive side of this vector? So let's start with that. I'm writing it down wrong. 0.749 newtons. So that is the magnitude of this force. Now, what direction is it? Is the force of 2 on 1 going to be attractive or repulsive? So let's look at these charges. So Q1 is positive, Q2 is negative. So these are opposite kinds of charges, which means it's going to be an attractive force. So which way will this force be? 2 is attracting 1. The question is, what is the force of 2 on 1? So the force that charge 1 is feeling due to charge 2 is going to be a pull upwards. So what does a pull straight upwards mean? In unit vector notation, what is a pull of 0.749 newtons in unit vector notation? What that really means is force of 2 on 1 is equal to, well, it won't have any I hat component because this is not being pulled left or right at all. And its j hat component is going to be 0.749 j hat newtons. So there's our answer for part A. So again, there are different ways to handle the math. The way I recommend doing the math for these problems is once you figure out your force, or whatever it is, later it will be different things like electric field, figure out the magnitude of the thing, figure out the positive number, and then has a separate step, figure out the direction, figure out the I hat, the J hat thing. Is this attractive or repulsive? Is it a push or a pull? Is it pushing or pulling up or down or left or right or at some angle? So think of that as a separate step. So that's why, even though we got a negative number at this point, we'll look at our final answer. It ends up being a positive number. The negative tells us that it was a pull. It was an attractive force. It means we have opposite signs, opposite kinds of charges. But it was a pull upwards, so it ends up being a positive number. So that's how that works. So let me see if I can squeeze in part B right here. So part B, what is the force of Q3 on Q1 in unit vector notation? Okay, so part B, step, what is force of 3 on 1, which I'm writing as F sub 3, 1, and this will be equal to question mark, I hat, plus different question mark, J hat, newtons. So that's what we're looking for. So to do the math here, what we've really got is F of 3 on 1 is equal to K Q3 Q1 over the distance from 3 to 1 squared. So this is squared and these are subscripts. So go put in your numbers. Again, the last step, or one of the last steps you should do when you're doing these problems, is write down exactly the numbers you're going to put in the calculator. So 8.988 times 10 to the 9th times Q3. What is Q3? Q3 is minus 9 microcoulombs. So minus 9.00 times 10 to the minus 6, because that's what micro means, coulombs, times Q1, which is again 5 microcoulombs. So 5.00 times 10 to the minus 6 coulombs. And all of this is getting divided by the distance from 3 to 1. So what's the distance from here to here? Check out the coordinates here. It's going to also be 0.600 meters. And that gets squared. Don't forget to square it. So if you do all of this, what do you end up with? You end up with 8.988 EE9 times minus 9 EE minus 6 times 5 EE minus 6 divided by 0.600 x squared. And we're going to get, let me write it down here, F sub 3 on 1 is equal to minus 1.1235 newtons is what I've got. So let's call it minus 1.2, minus 1.124. I'm going to round up. So that's what we have. And again, we need this in unit vector notation. So we figured out what this is, and what that really means is the magnitude of F of 3 on 1 is the positive number, 1.124 newtons. So I did a little bit of rounding there. And which way is this really going? So Q1 and Q3, we have a positive and a negative charge. So it's an attractive force. We have opposite charges. So if Q3 is attracting Q1, it's pulling it to the right. So that means this force is straight to the right, which means when we write this out, F31 is equal to all of its force. The only component of this is going straight right. So that means it is 1.124 I hat. because that is straight to the right, plus 0 j hat. So certainly you don't have to write plus 0 j hat. I think it might be helpful for me to write it because people are learning it and just I'm trying to be consistent about it. You wouldn't have to write the j hat part in this if it's just 0. So you get that. So that's your other one. And now quickly, let me squeeze this on this page too. Part C, what is the net force on Q1 in unit vector notation? So actually, I'm going to go to another page. We have run out of space. Hope you'll be able to see what's going on. So for part C, step we're looking for the net force. So what that really means is sigma F on 1. So sigma F1 is equal to, and we want something in unit vector notation. So question mark I hat plus question mark j hat. Newtons. This is what we're looking for. So what is that going to be equal to? Sigma F sub 1, let's do this with hats. Sum of the force on 1 is going to be equal to the force of 2 on 1. So our answer for part A with a hat plus the force of 3 on 1, also with a hat. So now to add these guys up, remember F sub 2 on 1 in unit vector notation is this. F sub 3 on 1 in unit vector notation is this. So to add these guys up, what we really have is sigma F sub 1 is equal to, I'll write it this way, F sub 2 on 1 plus F sub 3 on 1. Okay, and what is that equal to? F sub 2 on 1 is 0 I hat plus 0.749 j hat newtons. F of 3 on 1 is equal to 1.124 I hat plus 0 j hat newtons. So remember, when you're adding vectors in unit vector notation, it's very easy. Just add the things straight down. So 0 plus 1.124 I hat is going to give us 1.124 I hat. And what's our j hat part? 0.749 j hat plus 0 j hat gives us 0.749 j hat. So that many newtons, and that is equal to the sum of the forces on 1. So you put a box around it, you do step we solve for the right thing, sum of the forces on 1. We wrote it in the right way with the right notation. So it looks like that. So hopefully you're finding this helpful. These problems are not maybe super difficult other than the fact that there's lots and lots of pitfalls and you need to get practice in them so that you know how to handle things like positive and negative charges. So I've had opposite charges. I have a negative force. What does that really mean? Is that a force to the left or the force down? Not necessarily. A negative final force means a force of attraction. I'm explaining this poorly because that's actually not how I want you to think about it. Let's go back to this slide so I can show you how I want you to think about it. Again, when you're doing this stuff, we've done all the work. We've put in the numbers. We ended up with a negative number. I think the best way to do these problems is think of your force as being a positive number. So absolute value signs means give me the magnitude of the vector. So we figured out the size of this vector, and then the actual direction. We figured that out as a separate step. We figured out that, okay, what's the force of 2 on 1? Well, 2 is negative, 1 is positive, so it's a force of attraction. It's going to be a pull, and 2 is above 1. So that means 2 is going to pull 1 up. So that's how we figured out that the 0.749 newtons, if it's a pull up, that's going to be in the positive j hat direction. So that's how we ended up with this. So we did that for part A, this for part B. We got the other answer For part C, what is the net force? You just add them together. And again, when you're adding things in unit vector notation, line up your I hat terms. I could have lined them up a little bit better. Line up your J hat terms, add them straight down, and that's what you get. So hopefully you found that helpful.